We're going to look at finding equations of cubics in this section. Now, you might notice this guide is really similar to the quadratic one. That's because it is. The only difference is we have a stationary point of inflection. So if you have a point of inflection, remember the shape of it goes flat, so it goes up, flat, then up again, or it goes down, flat, then down. So this particular point is called the stationary point of inflection, or quite often I'll write POI. So when you see that, then you use the first form. Otherwise, you just put in points of any of the others. Now, there is one more thing, actually, I lied. See how this has a squared on it? Whenever you have a squared on it, think of it like a quadratic. When you have a quadratic, the particular thing that we normally look for is a turning point, which is why when it's x minus x1 squared, you have a turning point. That means if you have x minus x1 cubed, that'll be a point of inflection. So let's just see how this works. Determine the equation of the following. So A, the graph of a cubic polynomial which has a stationary point of inflection at the points -7, 4, and an x-intercept at 1, 0. Now, because we're only given one x-intercept, we can't use the intercept form. So we have to use the stationary point of inflection. Generally, whenever you see it, you should just use that one. And then substitute your values in. So it's x plus 7 cubed plus 4. Then put in the other point that you're given. Simplify it. So what do we have? 8 cubed. So that's -4. I shouldn't skip steps. So -4 equals to 8 cubed times a. A is then -4 over, that's 64 times 8, but 4 and 8 cancel, so we have 1 and 2. So that's 1, 2, 8. Then simply write out your equation. Y is equal to -1 over 128 x plus 7 cubed plus 4. Okay, part B. Now we have two x-intercepts given, but you might notice this one here is a turning point. So then what we need to do is we need to write out our equation, but with the turning point. So x plus 1, that doesn't have a turning point, so don't put a square on. One with a turning point, which is at 4, 0, you need to put a squared on. Then simply substitute the other point you're given, which is -5, 0. So then we get 16a to -5, so a is equal to -5 over 16, and then solve for it. Alright, part C, there's no turning point this time, so we just write out all three of the intercepts. Now we have a 0, so that will end up being an x. We have an x, we have a -3, so that becomes x plus 3. Then the other one is x minus 2. Substitute your point in. So we have 3 times 6, which is 18. Nice. Oh, I messed up. There was also a 2 here. 3 times 6 times 2, sorry. So 6 is 36. So a is equal to 1. Alright, when you're solving inequations similar to quadratics, you need to write draw out your sign diagram, and then once you've drawn out your sign diagram, you can easily tell which one it is. So, first one, we have intercepts at -2, +1, and +5. Now this is a positive cubic because there's no negative in the front. So then simply draw it out. Then we want the sections where it's greater than 0, so we want this top half. So that would mean x is in between -2 and 1, and also 5 and greater. For part B, rearrange it so that you have the x cube, the x's on one side. Factorize it out. Then do a sketch. So this time we have a 0 with a turning point because it's x squared. And then we have an x minus 4, so the other intercept is at 4. This is a positive cubic again. If you rearrange it the other way, you actually get a negative. But it shouldn't matter in terms of what values you get. Now that says you want the graph to be greater than or equal to 0, which is this section. But because it's also equal to 0, we have to include the point where x is equal to 0. So we have x such that it's at 0 and also 4 and greater. I read that wrong. X is such that x is an element of all of those. There you go. That's the correct notation. Right. If you wanted to write it out the other way, you can just write this little section out. You don't have to write the whole thing. Anyway, see. So this isn't a point of inflection. What that means is you'll kind of have to get a little sketch of this to see what it's like. It's at the point of inflection is at 2, -1, and again it's positive. So here's 2, -1. If we have a look, we want the section greater than 0, which is this section, which means we need to actually find the x-intercept. So our x-intercept is when y is equal to 0, so we have x minus 2 cubed minus 1 is equal to 0. Put the 1 over. Cube root of 1 is actually just a 1. So x is equal to 3. What that then means is we want 3 and to infinity, because we want it greater than 3.